In this example, we will learn the left shift and use it to perform bit manipulation. Let's begin. The goal of this problem is to take two 4-bit nibbles and combine them into one 8-bit value. This 4 bits here is going to be combined with these 4 bits to create one 8-bit value. In C, we see we could take one of the nibbles, shift it left 4 times, and then combine it with the other nibble to create the result. The way we're going to solve this is a 4-step process. First, we'll read the first nibble. This will give us these 4 bits. Second, we'll shift these bits 4 times to the left. The third step will be to combine the first nibble and the second nibble. And the last step will be to store the result. Now let's translate this into assembly language. We'll assume the first nibble is in this variable called high, and the first step is to bring it into a register. So, after executing the load instruction, register A has the first nibble. Executing the left shift causes a 0 to be shifted in the least significant side, and this 0 to be shifted out, moving all the bits 1 position to the left. When we execute a second shift, another 0 is shifted in, and again all the bits are shifted to the left 1 position. After the third shift instruction, we have 3 zeros down here. After executing the fourth shift, we see we have successfully manipulated the first nibble into the most significant bits of this 8-bit register. We use the OR instruction to combine the two nibbles into one 8-bit byte. And lastly, we store the result back into the variable. So in summary, we had a 4-step operation. We first read the high nibble. We shifted it 1, 2, 3, 4 times to position the first nibble into the top 4 bits. We combined it with the second nibble, and then we stored the result into the variable. Because there were zeros in the top 4 bits of the second part and zeros in the bottom 4 bits of the first part, we could have also used the add instruction to combine the two parts. One of the assumptions we made in solving this problem was the top 4 bits of the first part and the second part were initially 0. If this were not the case, we would have to make them 0. In C, we could make the top 4 bits of the first part 0 by ANDing it with 0f before we shifted it. And similarly, we could make the top 4 bits of the second part 0 by ANDing it with 0f before we combined it. In assembly language, we bring in the first nibble. Assume for a moment we don't know the top 4 bits of this variable. We use the AND operation, pound for immediate, $ for hex, to force those top 4 bits to be 0. Then we shift it 4 times, just like before. Next, I'll get the second nibble. Again, I don't know the top 4 bits of this second nibble. And notice I'm going to bring the second nibble into a separate register, so that the second nibble is in register B, and the first nibble here was in register A. I'll use the AND instruction to force these top 4 bits to be 0, so I'm going to AND register B, pound for immediate, $ for hex, and this will cause the top 4 bits of register B to become 0. One can combine two parts using either the OR or the ADD instruction. In this case, I'm going to add register B to register A, and the result will be in register A, successfully combining the two parts into one 8-bit byte. And just like last time, we'll store the combination into the variable called result. In summary, the left shift moved bits to the left, and we use the shift and the OR instruction to cause bit manipulation. When we want to move bits to the left, we shifted them to the left. If we wanted to move them to the right, we could shift them to the right. And we could use the OR to combine two components into one result. Thank you very much.